Hello and welcome to my channel. This video is about doing calculations in Newton's second law with USCIS or metric system units. The famous formula for Newton's second law is F equals ma, or F represents the force measured in newtons, abbreviated by a capital N. M represents the mass measured in kilograms, which is abbreviated as kg, and A represents the acceleration measured in meters per square seconds, where M represents meters and S represents second. 1 Newton is 1 kilogram meter per square second. We can use this circle to help us remember or derive the various forms of Newton's second law. If you cross out F at the top and you have ma on the bottom, when the variables are beside each other, that means you multiply them. If you're looking for mass, you cross out m. You have force on top divided by acceleration. So when one variable is on top of another, that indicates a division. When you're looking for acceleration, you cover up the A, and that would be force in the numerator divided by mass in the denominator. What is the force when the mass is 5 kilograms and the acceleration is 2.7 meters per square second? We make our formula circle. F equals ma. We're looking for force, so if we cover up force, we notice that force equals mass times acceleration. So we just plug in the values. The mass is 5 kilograms. So when you see the kilograms, that's how you know that's mass. And the acceleration is 2.7 meters per square second. So in the reading of the problem, that would be the acceleration. And you can work this out with the calculator. Multiply 5 times 2.7. Initially, you get 13.5 newtons. But in physics, we follow significant figures, and notice that your acceleration and your mass both have 2 significant figures, so we would round this to 14 newtons for the answer. Please pause the video and try this problem on your own, and restart the video when you have a solution. What is the force when the mass is 8.2 kilograms and the acceleration is 2.8 meters per square second? So we draw our formula circle. F equals ma. Cover up F. We know that F equals ma. So the mass is 8.2 grams, or 8.2 kilograms, and the acceleration, always look for meters per square second for acceleration units, that is 2.8 meters per square second. So what we do is multiply these numbers on the calculator. Initially, we get 22.96 newtons, but the mass and the acceleration both have 2 significant figures. So we would round this off to 23 newtons for our final answer. What is the acceleration when the force is 28 newtons and the mass is 9.8 kilograms. Well, first we go to our formula circle. F equals ma. We're looking for acceleration, so we cover up the a and we find that acceleration equals force divided by mass. So here's our force, that's always newtons, and mass is always measured in kilograms. So we just plug these values into the formula. Force is 28 newtons divided by 9.6 kilograms for the mass, and this will give us 2.916 repeating meters per square second. But notice that both our force and our mass have two significant figures, so we would keep around this or rewrite this answer as 2.9 meters per square second in order to have two significant figures. What is the acceleration with a force of 36 newtons and a mass of 3.8 kilograms? Please pause the video and try this practice problem, then restart the video when you have an answer. Let's go to our formula circle. F, M, and A. And we're looking for acceleration because the problem says, what is acceleration? So we cover up A in the formula circle. We know acceleration equals force F divided by the mass M. Now force is always in newtons, so 36 newtons is the force. Mass is always measured in kilograms, so the mass is 3.8 kilograms. Now we just substitute those values into the formula. The force is 36 newtons divided by the mass of 3.8 kilograms, and 36 divided by 3.8 is about 9.47 meters per square second. But notice that both your force and your mass have two significant figures. So we'll write this answer as 9.5 meters per square second in order to write it with the correct number of significant figures. What is the mass when the force is 42 newtons and the acceleration is 2.6 meters per square second? So we go to the formula circle, F, M, and A. Now we're looking for mass, so I cover up M. I notice that mass is force divided by acceleration. So in reading the problem, when we're looking for mass, that's M. Newtons is always your unit of force in the metric system, so 42 newtons is F. Meters per square second is the unit of acceleration, A. So now we'll substitute those values into the formula. 42 newtons in the numerator for the force, and 2.6 meters per square second in the denominator for the acceleration. That should be in M. And we go to the calculator, we find that the mass is about 16.15 kilograms, but we notice that both our force and our acceleration have two significant figures. So we would represent the mass, the final answer, as 16 kilograms. Please pause the video and work out this problem. When you have finished work, or if you have questions, please turn the video back on to check your answer or review the solution. So we're looking for mass m. Newtons always represents the force, so the force is 45 newtons in meters per square second. Always represents the acceleration, so 5.6 meters per square second is the acceleration. And we use our formula circle F, M, and A. We're looking for mass, so we know that the mass is the force divided by the acceleration, so that would be a force of 45 newtons divided by an acceleration of 5.6 meters per square second. So on the calculator, when we divide this out, we initially get 8.57 kilograms, but notice that both the force and the acceleration each have two significant figures. So we must represent the final answer with two significant figures, so that mass would be 8.6 kilograms for our final answer. I hope that this has led you to a greater understanding of Newton's second law calculations with USCIS or metric system units. Again, if you liked the video, please hit the subscribe button and give me a like. Thank you.